Alright guys, today's goal. The learner will understand how to apply properties of rational exponents. These are the same properties we used for the regular exponents, guys. So property a to the m times a to the n, what do you do when you multiply? They have the same base. What do you do with the exponents? We add them. Doesn't matter that they're rational exponents, because remember, a rational number, any number that can be written as the division of two integers. Okay? So we add them together, you get 5 squared, 25. Again, I'm more worried about this than I am this. More worried about this than I am this. So these are all the same properties. Power to a power, multiply. Multiplication inside the parentheses only, with it outside, you distribute. Negative means take the reciprocal of the base. Division means subtract. Only division or multiplication going on, distribute. Okay? But just like anything else, you cannot have one of the roots underneath or in the denominator. So you can't have a square root, cube root, anything in the denominator of the fraction. Okay? So here we go, simplify it. Are they the same base? No, so we can't do adding or subtracting. We only have the multiplication going on, so you need to distribute it. Well, 5 to the 1/3 times 3. That would be 5 to the 1/3 times 3 times 7 to the 1/4 times 3. So that is, well, 1/3 times 3 is 1, so it's 5. 1/4 times 3 is 3/4. Or to save a little space, 3/4. So it's 5 times 7 to the 3/4 power. Okay. I can't simplify anything here, so we move on. Now, see how the exponents are the same? So that means I could do this. Well, what's 20 divided by 5? 4. 1/2 times, so power to a power means multiply, so 1/2 times 3 is 3/2. So I have 4 to the 3/2 power, but what is that? Without a calculator. Remember now, 3/2 means you can do the square root of 4 to the 3rd. Well, what's the square root of 4? 2. 2 to the 3rd, 8. So we need to be able to do this and get to this without a calculator. Okay, so properties of radicals. Product property. See how it has the nth root of a times b, and we can separate it? We've been doing that. For example, when we simplify square root of 20, we can change that to square root of 4 times 5, which is square root of 4 times square root of 5. Well, that means for anything. Okay, so I look here. The 4th root of 27, not a whole number. 4th root, nope. So what can we do? We can change that to this. 27 times 3 is 81. The 4th root of 81, 3. So go ahead and press pause. Try to do this next one with the steps shown. Okay, so hopefully you did. And what would you get here? Cube root of 250 divided by 2. Cube root of 125. Well, 5. Okay. So simplify the expression. Alright, so first thing I would do is this. This would be 3/4 to the 1/5 power. And then this would be 3 to the 1/5 over 4 to the 1/5. See, here's the problem. Remember, we can't have roots in the denominator. That's why this is bad. So what you have to ask, I need this to be 4 to the first power. So how many fifths am I missing? If I have 1/5, that means I'm missing 4/5. So see how I'm multiplying the top and bottom by 4/5? Because what do you do with the exponents? So this would be 3 to the 1/5 times 4 to the 4/5 over, now we have 4, now that's 1/5 plus 4/5. So that's 3 to the 1/5 times 4 to the 4/5 over 4, because it's just 4 to the first. Now, see how these are both fifth roots? So what does that mean we can do here? The fifth root of 3 times 4 to the 4th. Because it's 3 to the first, because that's 1/5, that's the 4/5 over 4. So go ahead and use your calculator now. Do 3 times 4 to the 4th. You get the fifth root of 768 over 4. Now, see if it's divisible by a fifth root. So what I would do is 2 to the 5th power. That's 32. Can I do 768 divided by 32? Yes. So I can change this to fifth root of 32 times fifth root of 24 over 4. Well, the fifth root of 32 is 2. Fifth root of 24 over 4, but then that would simplify to fifth root of 24 over 2. Okay? If you need to, rewind and replay that, but try to soak that in. So I look at this. Simplify assuming all the variables are positive. They have to be positive. Okay. So I could change this as 27x to the 9th to the 1/3 power. And remember, if you need to, that 27 has a 1. So now if we distribute this, well, that doesn't look good. So now if we distribute this, you would have 27 to the 1/3 times x. Well, what's 9/3 times 1/3? 3. Cube root of 27, because that's what 1/3 means, is 3, so I get 3x to the 3rd. Okay? So this one, let's see, we have x to the 10th, y to the 5th, all that to the 1/5. Power to a power means multiply. So 10 times 1/5, 2. 5 times 1/5, 1. Okay? Again, we're assuming they're all positive still. Alright, so 6 divided by 3, 2. What do you do with the variables when you're dividing? You subtract. So I have x to the 1 minus 1/2, y to the 3/4 minus 1/2. Okay? We got rid of the whole bottom, so that means it's a 1 right now. So I have 2x to the 1/2, y to the 1/4. We don't need a bottom at all. There's no negative number, so. Or you could have said 2 times the square root of x times the 4th root of y, but that's, I would leave it just like that. Okay, so change the first one. See how it's roots? We don't want to deal with roots. We want to change it to exponents. Oh. So we can say r w to the fifth to the 1/2 minus w times w to the 1/3. Nope, not 1/3. That's square root. See, there's a mental mistake here. So it's 3 stays on the top, the root goes on the bottom. Okay? So this one we have to distribute, so 9 to the 1/2, w to the 5/2, minus w, and then this would be 1 plus 3/2. Well, square root of 9 is 3. And 1 plus 3/2 is 5/2. So I can factor out and get 3 minus 1, which is 2. So you have 2w to the 5/2. Alright, if you need to, rewatch this a little bit, but it should make some sense. So just make sure you guys are ready to roll. Okay?